Good afternoon, students. I hope that the test didn't frustrate you too much. Anyways, I'm going to go ahead and teach you lesson 5.1, which is slope and rate of change. Can you believe we're already in chapter 5? We have to finish this one, and then chapter 6 is our final next week. Okay. Sorry, I'm just trying to do this so that it's focused. Anyway, so let's go ahead and talk about slope and rate of change. First, I want to start with rate of change. Rate of change can be used with this formula, the change in your y value over the change in your x value. Okay? Rate of change is constant. Okay, I'm going to go ahead and circle this word constant. What do I mean by that? Meaning that if two quantities are changing, then they are changing at the exact same ratio. Okay? They're changing at the exact same ratio. So, like for example, if a price goes up $1 on something, then maybe like something else, the price will go up 50 cents, something that's related to it. So then the price goes up another $1, then the other one, the price goes up 50 cents. Okay? That's usually actually what happens. Like when they start raising up minimum wage, like when you get a job. So like let's say like minimum wage now is like $13. Well, let's say they raise it to 15. Then when they raise that to 15, then the price of everything else goes up. So it's so when things change, it's like one thing changes, then it causes everything else to change at the same rate. So that's what we mean by rate of change. Now, I made a simple table of values here. My ordered pairs are 110, 220, 330, and 440. Okay? I want to show you how rate of change works. In order to find the rate of change, you would take one set of values and then you subtract from it the previous values. Okay? Or not, rather, subtract. Well, yeah, you subtract. Okay? So let's take a look at my y values here. My y value is 10. Well, I'm sorry, let me start with 20 because rate of change, you want to kind of like, the idea is you start at wherever you're at and then you go back to the one before it. So it's 20 and then 10. Okay, so in this case, to find the rate of change, I take my, the change in my y value, here's my new y value, minus the previous y value. Okay, that's how I find the change in the y values. So what is 20 minus 10? That would be 10. Okay. Now, the goal is to do the exact same thing with the x values. If 2 is my new number, 1 is my old number. Okay. So the change in y values is the difference between the new value and the old value. Okay, so 2 minus 1 is 1. So the rate of change is 10 over 1. Okay, now the question is, if this particular table here is a function, then this should work with the next numbers. So the next numbers are 40 minus 30 and 4 minus 3. I'm color coding it because I just want to connect the work that we're doing to the table that we're getting the information from. Okay, so 40 minus 30 is 10. I think I'm off the screen here. Sorry about that. Let me just scoot my paper over. So 40 minus 30 equals 10. 4 minus 3 equals 1. So if you look, the rate of change is the same, even though I subtracted different numbers. Well, what if I say, for example, I took 4 and 40 and then 1 and 10? Okay, so I'm just going to pick random numbers here. So I have 40 minus 10, and I have 4 minus 1. Okay, now I'm going to color code them to show these are my y values and these are my x values. Okay, now 40 minus 10 is 30. 4 minus 1 is 3. Okay, so I get 30 over 3. But wait, it's a fraction, it's a ratio, but it's not in lowest terms. So let me simplify this. I can divide them both by 3, and I get 10 over 1. Well, look at that. It's the same ratio, okay? So rate of change, you can go from any x and y pair minus any other x and y pair in the set, okay? So if you do it that way, then you will always find the proper rate of change. Well, what if you did it backwards? Okay, you're like, well, you said you could use any, Mr. Bauer. All right, let's do it backwards. We'll take 30 over 3, and then 2 over 20, okay? So I've got 30 minus 20, and what was that? 3 minus 2. Okay, so what I'm going to do is I'm going to switch it, and I'm going to do it backwards. And I'm going to go 20 minus 30 and 2 minus 3. Okay, I'm literally doing it backwards. So 20 minus 30 is negative 10. 2 minus 3 is negative 1. So I have negative 10 over negative 1. But when you have a negative divided by a negative, the negatives cancel out and they turn positive. So I now have 10 over 1. So even if you do it backwards, then you will still get the right answer. Okay? So each time I got 10 over 1 as the rate of change. Okay? So the rate of change I would just say is 10. So basically, for every, we'll just say if these are minutes and these are feet or something like that. So every 1 minute, the item moves 10 feet. In 2 minutes, it moves 20 feet. In 3 minutes, it moves 30 feet. 4 minutes, it moves 40 feet. So it'd probably be something relatively slow if it moved at a rate like that. Maybe like a turtle. I think a snail would take it all day to move 40 feet, but a turtle could, that's probably about right for a turtle. Regardless of what application we give to the numbers here, the point is your independent value, your x value, is in a ratio with your y value here. But since this is one table of values that are connected, then you can go from each x and y pair and come up with the rate of change. Now again, rate of change is change in your y value. So y value minus the previous y value over change in the x value, which is x value minus the previous x value. Now I color coded them because I really want you to make sure. People sometimes make the mistake, they see 40 and 30, and they put 40 on top and then 30 on the bottom. No. Your x values are on the bottom, not your y values. Now I know it's a little bit complicated because in the table we usually write them vertical, and then this we're doing horizontal. Okay, so it can get a little bit confusing. So make sure the y is always on top and the x's are always on the bottom. Okay? Now I want to talk about slope. Now slope is vertical change divided by horizontal change. It's commonly called rise over run. Okay, this is easy to remember, rise over run, so please try to memorize it in that form. But I want you to understand what it means. Now, when we say vertical change, vertical means up and down. So we are talking about a picture. And a picture in mathematics is called a graph. Okay? So in this particular case, vertical change divided by horizontal change means how much of a difference there is vertically versus horizontally on the graph or on the line that's on the coordinate plane. Okay? So that's a good question. Now, to find vertical change and horizontal change, there are a few different ways that you can do that. Okay? So what you want to do is pick a particular point on your graph. Okay? Now I'm going to go ahead and pick this point right here. And then you go up or rise however many spots it would take you to put you perpendicular to the next point. Now, I went up 2 spots, and the reason why is because if I go over here, then I can see that my next point would be over this way. Okay? So, I went up 2 spots, so my rise would equal 2. I went over 1 spot, so my run would be 1. Okay? So in this case, my slope is equal to 2 over 1, or I would just say my slope is equal to 2. I want to remind you, when you have a denominator of 1 in a ratio, remember we also called that a unit rate, but when you have a denominator of 1, you can also write the ratio as a whole number. So 2 over 1 and 2 mean the same thing, so it's just more simple to call it 2. Now you notice I use the red, you probably can't see it because of my background, I used a red pen to represent the height, and I did a blue pen to represent the width. Just, I don't know, you don't have to color code things, it just helps me to recognize the difference. So slope, again, between any 2 points, now I want to remind you, this little green line that I drew here, some places it doesn't go through a point, like right here, it's just going through the white, there it crosses a line, but here it's on a corner of the graph. And so when I say a point, I mean kind of like one particular corner. Now, what if I picked different points? Okay, so let me start with a point all the way down here. And let's go up to this point right here. All right, so again, starting with the red, I'm going to do my rise first. 1, 2, 3, 4 spaces up. Okay, so my rise is 4. Now let's do the run. 1, 2 spaces over. So I have 4 over 2. But if I reduce the fraction 4 over 2, I get 2 over 1, which equals 2, which is the same slope that I had before. Okay? So as long as I'm going from any actual points that my graph is on, it doesn't necessarily matter, because if I get a larger number for my slope, 4 over 2 will reduce to 2 over 1. And it works if I went super huge. Okay, I think that's 10. 1, 2, 3, 4, 5. So I now have a slope of 10 over 5, which reduces to 2 over 1, which reduces to 2. Okay, so as you can see, between any 2 points, my slope will always be the same if I reduce it. Now, to save yourself time, if you can, you might want to pick the smaller rise and the smaller run when you're finding slope. The purpose of that would just mean you save the step of having to reduce. Okay? Now, what if you don't have a graph and you just have some numbers? You have like a table here. Okay? We have something that's called the slope formula. I'm going to ask that you memorize this formula because you're going to be needing it. Okay? The slope formula is y sub 2, meaning your second y value, minus y sub 1, meaning your first y value, over x sub 2 minus x sub 1. And the sub numbers, it looks like an exponent, but it's written low in comparison to the base number, or base letter in this case. The low numbers just means numbers in sequence or numbers in order. Okay? Now I said your second y number and your first y number. Going back to this table here, remember we did rate of change and I picked different y values. I compared like the last set to the first set of y and x values. So we say y sub 2 minus y sub 1 and x sub 2 minus x sub 1. If you have a table and there's many different values on there, honestly, you can pick any two pairs of values. It doesn't have to be literally the first one and the second one, okay? But the purpose is when you are trying to figure out exactly what I'm trying to say here. The point is when you find the slope, any of the pairs will work, but to make it as simple as possible, you probably want to pick your first and second numbers in a table. Okay? Now, I'm going to go ahead and just write a table of values here. Okay. Now, I just want to show you how the slope formula works. Okay? So the first thing I'm going to do is I'm going to go ahead and write a slope formula line. I'm going to put a couple of minus signs here. Then I'm going to color code my table. These are my y values. These are my x values. Okay. Now, having done that, I want to remember I put my y values here, and I want to put my x values here. So y sub 2 means like my second y, or a later y number. So that would be 5 minus y sub 1, which would be 3. Okay? And then I want to use the corresponding x values. Okay? So x sub 2 has to be the x value that is compared to y sub 2. Or in other words, I'm picking this number as my second y value, then I must pick this number as my second x value. Don't get them mixed up or order changed or anything like that. So that would be 4, and x sub 1, same thing. If this is my sub 1 number that I'm going to be using for my y value, then this has to be my sub number I'm using for my x values. Okay? So I have 5 minus 3 is equal to 2. 4 minus 2 is equal to 2. So my slope is 2 over 2. Now you may remember this from 6th grade pre-algebra or fractions. Anytime you have a number over a number, it is equal to 1. So in this case, I have a slope of 1. Oops, it would help if I spelled slope correctly. Slope equals 1. Now I have a little hint here for you. Just to save time, the letter M is a symbol for slope. So sometimes if you want to write slope, you can actually write it like this. M equals 1. I think we'll be going into more detail on that in a later lesson, but instead of having to write out the entire word slope, M has been chosen to be the symbol for the concept of slope. Now, I just want to clarify a few things. When you see a line on a coordinate plane, and in terms of its orientation from left to right, if it is going upwards from left to right, then we call that a positive slope. Okay, remember that. Up from left to right is positive. I'm just writing that out for you. Now, the opposite is also true. If the graph or the line is going down from left to right, then we call that a negative slope. Okay. Now, if you have a line that's totally flat, then we just call that zero slope. Okay. And obviously, if it's totally flat, it doesn't matter if it's going from left to right or right to left. Now, keep in mind the word slope is often used to represent like a mountain. You know, you're driving on a hill or you're riding in a car and you see a sign that says slope 6%, which just means that the downward slope is it's the same idea, but it's just the ratio of your rise over your run. And they just decided to write as a percent because it's a little easier to understand when you're driving on a road. Okay, so 6% slope would be, once you've done all of this dividing, would just be 0.06 as a decimal, or 6 over 100. Yeah. Okay. So literally, what they did is they did the same thing. They did rise over run, and they got 6 over 100, and they just decided to call it 6%. Okay. Either way, zero slope means that there's the absence of any slope. So slope is vertical change divided by horizontal change. If there's no vertical change, then there's no slope. Okay. However, if a line is completely vertical, it's called undefined slope. And I'll write it this way so you can actually read it better. Undefined. Okay. So we call it undefined slope. Like, for example, zero slope, if I were to give you a number for it, then the rise would be 0 and the run could be anything, okay? But I have 0 divided by 2. Well, I can't divide 0 by 2, so there's nothing to divide, okay? But if I have a perfectly vertical line and no horizontal, then it could be like, for example, 2 divided by 0. Well, 0 means nothing, and you can't divide something by nothing, so that's undefined. In other words, it doesn't make sense. So with a perfectly vertical line, when we're talking about slope, is we call it undefined, okay? Because you can't divide something with nothing. The other thing is using the example of, like I said, a mountain. You know, you're driving up a 6% grade or slope. If you have an undefined slope, then it would be just like falling off the edge of a cliff. I mean, there's nothing. It's just straight down. Okay. Hope that makes it clear. I'm going to stop share and please enjoy the video.